Hello everyone, welcome to my presentation on BioBotanica Next-Gen Medicinal Plant Detection using Generative AI and RAG. I am Vijay Rai from Department of Information Technology, third from the batch of 2022 to 2026 from Savita Engineering College. Presenting this project under the guidance of my mentor, Mr. Manoj V. from the Department of AIDS. Okay, let's go to the project. This is the agenda for this presentation: introduction, statement of the problem, purpose of your project, proposed methodology, expected results and its implications, literature review, project plan, conclusion, and references. Let's dive into the introduction. Introduction: the medicinal plants are vital for healthcare, research, and conservation. And then conservations, traditional identification methods are slow and expertise dependent. BioBotanica aims to solve this by leveraging ResNet for plant classification, RAG for concise, reliable medicinal insights, making plant knowledgeable access to all. The purpose of this project has four main goals. The four main goals to accelerate plant identification, enhance accessibility to biobotanical knowledge, support healthcare and research, and serve as an educational tool for botany. These objectives align with addressing the challenges proposed by traditional methods. The statement of the problem: the identification and utilization of medicinal plants are hampered by slow expertise dependent methods that limit accessibility and time applications. So, to reduce this, we dive into this project, BioBotanica, to classify the plant, and with the help of the AI, we can generate the text of the users and their health benefits. The scope of the project: to automate the medicinal plant identification from images, we provided concise information and their medicinal properties, making expert botanical knowledge widely accessible. A user-friendly tool that can classify plant images and generate very accurate summaries of their medicinal benefits. We use the data we use is an image dataset and textual data. Then the target audience are the healthcare professionals, researchers, educators, and the plant enthusiasts. The main goal: to create a reliable AI-powered platform that enables users to quickly identify medicinal plants and access verified, concise information and their medicinal properties, health benefits. Make expert botanical knowledge available to a wider audience, reducing the need for specialized expertise. So that we use AI to these converse. Okay, the deliverables is a user-friendly application that accurately identifies medicinal plants from uploaded images. Our limitations are data dependency and the image quality and specialization constraints. The methodology we used in this proposed system is data collection, image processing, plant classification. For the plant classification, we used ResNet model, classifies the plant species with high precision, trained on a large data set of medicinal plants. We used the for information retrieval, RAG, to give the external data knowledge base to the AI model. We used some data summarization language model that retrieved data into a brief 3 or 4 line summary on the plant's medicinal use. Display the result using the Streamlit platform, and the testing and the validation are concise and very precise. The architecture diagram flow of this is our proposed system on the project. We use the user interface as a Streamlit. We upload an image that process and pre-process the image that sends to the ResNet 50 model, which classifies the plant data. That's the generative AI model, which generates the text. Then the generated summary display in the user interface as a Streamlit. The use case diagram and the class diagram, the sequence diagram, and the algorithms we use is the ResNet and the Retrieval-Augmented Generation, and the language model we use P5 Hugging Face and the purpose function. Okay, depend extremely Torch Vision, OpenAI, Transformers, Pillow, and Requesters. Okay, hardware selection we used mostly we trained the model using the GPU of our laptop with the NVIDIA GTX 1080. The memory, at least 8 GB RAM is recommended. 16 GB is or more is ideal for handling larger datasets and models. Storage sufficient disk space for storing datasets, models, and dependencies. At least 10 GB free space is recommended. Okay, the frameworks we use for web application framework, we used Streamlit to building the interactive web interface that allow users to upload images and view results. The deep learning framework, PyTorch and Torch Vision are used here. And natural language processing tools, we used OpenAI API for the text generation and other properties to build the knowledge base as a important in this project. Okay, implementation steps: collect and prepare data, develop image classification model, integrate information retrieval component. These are the implementations and the code for these segments. The output is there. Let's dive into this our project demonstration. We demonstrated the project in this Visual Studio Code. In the app.py, we stored the necessary code to display in the Streamlit functions. So the data processing file is for the pre-processing of data. The model training in this code, we trained the model. From this dependencies, first we have to select the device. Then we have to print the which device are using, like CPU or GPU. Let's data path in the dataset image folder. Then we have to use the necessary codes to pre-process this data. Then after that, the RAG generation, we integrated a chat GPT-4 for the text generation. The external knowledge base is connected to the chat GPT. So okay, let's run this application. Here we get this. Let me test with the aloe vera. Here are the results. Simply, we put the image in this drag and drop file here in this section. It classifies as the image as the aloe vera. Then the use of ChatGPT generates the text. The final model achieved the accuracy approximately 90.67. The graph which shown the laws and the approaches we use on this project for the model. The conclusion: the BioBotanica next-gen system significantly simplifies the identification of medicinal plants, making expert-level botanical knowledge accessible to a broader audience, which democratizing the of knowledge supports informed decision-making in healthcare and promotes the sustainable use of medicinal plants. We are here at the future work. In the future, we can include the multilingual capabilities, user feedback mechanism, collaboration with botanical institutions, image and data analytics, educational models, and augmented reality integration. These are the reference we taken. Then thank you.